Hi, everyone, and welcome to the after show of the AI Hardware Show 2023, episode 5. This episode's been a bit of a wild roller coaster. I think pretty much every chip we've spoken about is completely different to every other chip.
So much variety in the sector, right? That's why it makes it such a joy to be in this industry.
Either that or we planned it pretty badly.
One of those two things.
Yeah, one of those two things. But to start off, as we always do with these after shows, let's go through what we spoke about in order. Mobileye. I started speaking about Mobileye. Now, Mobileye is self-driving. It's hard to mention self-driving in the sector without saying Tesla, but Mobileye is, a pretty strong number 2 right now. With Tesla, in an earlier episode, we spoke about Dojo, their supercomputing, AI learning, let's label video data type of system. Whereas with Mobileye here, what we're actually talking about is the chip inside the car. Tesla has full self-driving, and Mobileye has their EyeQ series of SoCs. Right now, they've got the EyeQ 5, which is in a number of deployments. You only need 1 chip for a level 2 plus car and 6 chips for a level 4 car. I actually got to try this in Israel back in September.
I'm so jealous.
Intel invited a bunch of us out to their foundry, and then
my invite lost in the post, obviously.
So the self-driving tour, it was just 10 of us, the analysts. So unfortunately, if you'd have gone, you wouldn't have got access anyway.
Okay, still don't get to do it.
But the thing is, it's surprising that it was perhaps surprising that was my first time in a self-driving car.
So I've been in a Tesla on the autopilot mode.
Yeah.
Only for the first time quite recently, actually. But for the full autonomous vehicle experience, I really would love to do that.
So if you've never been to Israel, I don't blame you, but it's the people driving there. So they programmed a 10-mile route for us.
Okay.
And people are insane.
The driving conditions.
Yeah. I mean, if you've ever been to Eastern Europe, some of them places are insane.
Okay.
But we went through locations, some of which had road markings, some of which didn't. At one point, we had bikers jump out in front of us to go off the road ahead. But either in the level 2 plus or the level 4, we had no interventions, as in at no point did the driver have to get on the, hold the steering wheel and actually take control. Apparently one of the other groups had one intervention in the level 2 plus, but not in the level 4. And, it took into account the traffic lights and all the cars parked on the side of the road, and it just followed a predetermined route. Okay, but that's experienced self-driving. What's that got to do with AI chips? So EyeQ 5 is what's in now, but the CEO last year, early 22, announced EyeQ 6 and EyeQ Ultra. Next generation parts, EyeQ 6 immediately, EyeQ Ultra for the future. And it's this EyeQ Ultra that I went into during the show. Because the idea is for level 4, rather than having 6 of these EyeQ 5s, you only need 1 EyeQ Ultra.
Okay.
And built in, you essentially have scalar, vector, matrix, and spatial compute. So CPU, GPU, tensor, and CGRA, all in the same design. So the idea is that no matter your model, no matter your workload, everything can go into this chip. It's about 100 watts, engineering samples end of 23, full silicon by 25, production, and then one of the big Mobileye deploying right now is a company called Zeekr.
Okay.
In China.
Okay.
Unfortunately, we didn't get one of those. The cars we drove in were like a Ford Fusion and something else. So they actually told me off a little bit because they had a little screen showing what the AI was seeing. And I went, what does this button do? Ooh, developer mode.
Oh, no. Okay. Crash.
No. All it showed was the frame rate it was running at doing the calculations. Though they said that may not be accurate because it's not a retail version. Because it did say FPS 10, and I thought, don't you need a bit faster for that on the road?
I'd have thought
maybe,
so.
Maybe not so much more.
What do I know?
I mean, if you have an FPS of 10, that means your reaction time from seeing to acting is 1/10 of a second.
Okay.
That's racing car driver reaction times. Normal people, when you see something on the road and you react, it's about half a second.
Yeah, okay.
So maybe we don't need 30 frames a second in these cameras. They also have LiDAR and map brain, which is different to how Tesla's doing it. But
yeah, famously, he only wants cameras in the Tesla, right? It's a different.
Well, I mean, that kind of makes sense if humans only need vision.
Yeah, but
and it's
humans have other senses. Humans hear things as well, right? You can hear something coming.
Not the deaf ones.
Well, no, that's true. I don't know. I think, why wouldn't you want all the data that you can possibly get? Why wouldn't you want LiDAR, for example? Why
Cost.
wouldn't you? I don't know. I want that in my self-driving car.
It's I did a poll on my Twitter, I think in 2020, and I said, how much extra over the base price would you pay for full level 5 self-driving in your car? 0%, 10%, 20 to 30%, 40 to 50%. And so I'm somebody who doesn't actually have a license.
You don't drive?
License.
Okay.
The one time I drove were Ferraris in Italy.
Okay.
As part of a vendor event. Nobody asked if I had a license. And I just drove and okay. So I go karting. I know about racing lines. I watch Formula 1, whatever.
You weren't on the road. You were on the track.
I was on a track.
Yeah.
I was on a track, and the instructor next to me, she must have had an imaginary brake pedal because I was hearing some deep bass thumping. So for me, I see driving either driving for me is bimodal. It's either utilitarian or it's sport, right?
Sure. Yeah.
I'm either getting A to B or I'm doing it.
I'm enjoying my drive. Yeah.
I don't and I'm doing it on a track. I guess I don't kind of drive. Yeah, I know people have like Sunday lazy drives where they're just in their own head and whatever. I'm not that sort of person. So for me, a fully self-driving car already has a name. It's a taxi.
Yes.
So how much would I be prepared to pay for that? How much would you be prepared to pay for fully self-driving?
Yeah, it's a great question, particularly regards the taxi point, which I really, really agree with. I'm a taxi user, a heavy taxi user. I don't know how much of a premium. I suppose if it literally is doing all the driving, like I get in my car, I literally go to sleep and I wake up at my destination, and it drives all night for me, then I'd say I'm going to pay a premium, pretty hefty premium for that. Is that 30% to 40%? I don't know, but
I think for me, 40 to 50, right? It's if I'm paying 25, 30 for a car, would I pay 45, 50 for something which is fully autonomous? As long as it told me when to get the oil changed, and it doesn't automate that stuff, for example.
Insert fuel now. Yeah.
Maybe it does. Maybe when it senses that you need a service, it will drive itself to the dealership.
I hadn't considered that it would drive around without you.
Oh yeah.
Okay. Yeah. Okay.
So the whole point is you get off at your destination,
and it goes and parks up somewhere,
and then you just like the Teslas, you can actually pull it out of the parking space.
Okay.
But do that on a the downside. So robo-taxis are obviously one of the big deployments people are expecting, but also long haul with self-driving. The only issue is, and this isn't AI related at all, but you may be in a situation where not only are you driving around and most of the cars on the road are empty, which is not very good for the environment, whether you're electric or not. But people may actually be deceased in those vehicles, and you may never know.
What? It's just driving around.
Okay. There's eternal driving around.
Yeah.
And then there's driving around and just in a thing to go home. But imagine you have a program set in your autonomous vehicle that is take me to work.
Yep.
9 o'clock every day, or to arrive at 9 o'clock every day and take me home at 5 o'clock. You, God forbid, stroke, heart attack, pass away in your vehicle.
Just conk out in the middle of the drive to work. Okay.
Right. The car parks up at work, shuts down for the day. 5 o'clock detects you're there, drives you home, charges up in your garage, and then
just brings you to and from work.
Yeah, and until somebody realizes That could be a thing.
I don't know.
We need the AI to
I've
detect.
I've seen applications like heart rate monitors in the seat that's supposed to tell if you're getting angry while you're driving, that kind of thing.
Oh, and that's sort of
or if
facial.
you're falling asleep is the one, if you detect if you're falling asleep. So I feel like maybe they could detect if you'd actually died.
Well, so the whole thing about saying like the face monitoring about anger and stuff, that again using machine learning, but I've seen insurance companies talk about using that. So if the AI thinks you're an aggressive driver, maybe your premiums go up.
Yeah, okay.
Well,
does it listen to my language as well? Because
well, I was going to say, surely that depends who else is driving on the road that day sometimes, right?
Yeah, it depends on traffic conditions. Yeah.
So, okay, short story aside about deceased people driving around in autonomous vehicles. Recommendation engines.
Yes. Recommendation, like totally different from what we're just talking about, obviously.
So what is a recommendation engine and why is it important? I think we very need to stress this.
We need to stress how important this is. Recommendation as a workload is powered by AI, but it's the kind of algorithm that is selecting, Netflix suggesting what film might you like to watch next, or you're on Amazon you're buying something and it's like, you just bought a tennis racket. How about these tennis balls or whatever?
Well, okay. So it's recommending stuff that to either watch or buy or showcase
or social media news feeds. What are you most likely to engage with?
Right. So perhaps not the social media feed, but for Amazon and stuff like that, if people are buying tennis balls with tennis rackets, that doesn't necessarily mean it's machine learning. That could just be literally.
So
these two items are bought by people 28% of the time, so therefore we're always going to recommend it. That's what I would call algorithmic or heuristic.
So if let's say it's the Netflix algorithm and it looks at what kind of films do you like to watch and what did other people watch that like the same kind of films as you. So the features might be stuff like.
Well, that still sounds
is it a comedy? Is it more like animated movies, a kids movie, and all these different features combined. But then you train it. You use machine learning to learn all the features and everything as well. It's not just. And obviously, if you're Amazon and you have how many millions of items, you need to use machine learning to. You can't hand suggest something for every single product.
No, but it's just you look at the union of different items and the max. Okay. So put it this way. Perhaps I can answer my own question, kind of. It's if it realizes that you watch 2 episodes of comedy, then 1 of horror.
Okay.
Then once you watch that second one of comedy, it knows to recommend you another one of horror. It learns what you do.
Yes. Okay.
And on the Amazon front, now people always say, why is it suggesting items for me that I haven't even searched for, that I've only spoken about to my friends? And I have the answer for this.
Okay.
One potential answer. So, say you're looking for a new lawnmower.
Yeah.
You've mentioned it to a friend who's into their lawnmowers. Whatever, or painting, and you want to look for paint stuff. What Amazon knows is that your device has been in close proximity with somebody else's device.
And they search for.
And they are active in that side. So it surmises that you may have spoken about what you're interested in. And as a result, it decides to show you what you may have spoken with that person to. Now, of course, if you commute regularly, then that's one thing. Maybe it detects you being stationary next to somebody. So after this, I'm going to get a bunch of your search results. And
okay, yeah.
Mine.
Yeah.
So you're going to get a bunch of chip results.
And you're also going to get chip results.
Oh, so no difference.
Yes, okay.
So recommendation engines are important. We're speaking about billions of dollars hanging on 1% accuracy.
Yeah, absolutely. Big business for the hyperscaler. And if the accuracy is super important, because if you're Amazon and can predict very, very accurately what the person's going to click on next or what they're going to buy next, if you have to reduce the accuracy in any way, it's like there's a sales figure associated with that. There's millions of dollars potentially associated with those percentage points in accuracy. So it's big business.
Okay, so argument's sake, 2 percentage points is $500 million.
Okay, wow.
Right? So why doesn't Amazon just go build a chip with that extra money?
This is a great question. Build recommendation chips, right? You'd think so, wouldn't you? A lot of recommendations still done on CPUs, Intel CPUs today.
Just because they're so configurable.
Just because you need that flexibility, and because if you are going to use it more like a general purpose data center accelerator, it's very, very hard workload to accelerate. Memory bound, memory capacity bound, compute bound at different times. So you have these huge embeddings which take gigabytes, and then it's all related to the memory size and stuff. So it's very, very different to any other kind of workload.
Super sparse.
It's totally crazy. So you'd think it'd be ripe for let's make a recommendation accelerator exactly for this workload, given that it is so different. And we do have a couple of companies now in this space working on recommendation accelerators, and Neuchips, so we're talking about here from Taiwan, is one of them. They have a completely original design with accelerators for all the different bits of the workload. They have impressive power figures as well. These it's not like let's replace hundreds and hundreds of watts GPU. It's more like this is an accelerator that someone has little modules that you plug in. Right. It's like it's taking part of this part of the workload. But Neuchips have some great ideas about let's make our own floating point formats as well, of course. Very trendy again in the industry, but they use at least half a dozen different formats, and their compiler basically chooses which formats are best.
So depending on whether you need range or accuracy and in which area, but at some point people need new wheels and decide to reinvent them.
I guess so. To be honest, it surprises me that there aren't more recommendation-only plays. Maybe people think hyperscalers are building their own chips for this. Yeah. But we haven't seen any. I haven't seen any from hyperscalers. They haven't spoken about it.
Well, we're seeing some hyperscalers build out, say, new host chips, either based on ARM, like Graviton, but that's for services. And then we've got, is it Alibaba's got Yutian, or is that Tencent?
So the Chinese hyperscalers for sure. AWS has Trainium and Inferentia. Google has the TPU. So there are a few different plays around, but
I guess even serving ads is recommendation engines in a way.
Absolutely.
And that's 90% of Google's revenue, isn't it, or something similar?
Like I say, this is big business that we're talking about here.
Yeah,
it's it's not a small amount of money. So with the market so huge, it's like there are a few customers, but if you get into that one customer, you can sell a lot of chips, right? Yeah. It's a little different to almost any other use case because it's so specific to hyperscalers.
Yeah.
But
people just with big platforms.
Yeah.
Right, and big platforms and hundreds of millions of customers. I mean, maybe Twitter needs a recommendation engine soon. That sort of thing, yeah.
Yeah.
Social media, you
social media news, social media news feeds. So let's buy some Taiwanese hardware, accelerate it all for very low power. Or there is at least one other recommendation accelerator company that we'll talk about in another episode coming up. But it's maybe you think it's niche. If you're watching this, you think it's super niche, but it's very interesting nonetheless. So,
well, I mean, so speaking about low power, the next chip we spoke about was Lightmatter Mars, and it's again another completely different aspect. Let's speak about optical compute. And optical compute, I mean, we were speaking about this off camera. It's interesting and complex and everything else in between. So the point is, in order to do any sort of compute, digital compute, you have switches. That's transistors in a chip. They're just little switches. So what's the optical equivalent of a switch? Well, they have this thing called Mach-Zehnder interferometer.
Yes.
So you have light go in, you split it, you apply a voltage to change the path of one of them.
So you change the refractive index on one of the waveguides, and for light matter, it's mechanical. They literally squish the waveguide to change the refractive index. It's a physical movement. Changes the phase so that you get destructive interference when they join together.
Or constructive if you actually want it to be together.
Yeah.
And the point is, if you have an array, so it is essentially a one-bit operation.
So it's analog compute. So the max ender gives you the multiply part, modulates the light as a multiply, and then you can literally just join the wires together to make the add part.
Yeah.
Or accumulate, as we call it in computing.
Yeah, and so you just have a massive array of those. Yes. Like Lightmatter are saying, they have they can do 8K 8-bit int ops.
Yes.
Per cycle, but there's no cycles in light. So they say 200 picoseconds. I forget the calculation of what frequency that comes out to. I want to say 25 gigahertz or 5 gigahertz or something.
I can't do that in my head.
But it can do all this for 3 watts. Now, you still need the laser.
Yes, there are other bits of the system. There is, of course, like we're talking about, an electronic ASIC on top that feeds all the data in, as well as power associated with that, and that has to run very fast in that as well. Yeah. So, yeah, and the laser and the other parts. But it's so cool. It's just so cool. Shining a light, and then it shines through this chip, and then somehow you get the answer at the end.
Like a grate. It shines through a grate.
Yeah, basically. It's brilliant. I think it's brilliant.
It's so they said the chip is 3 watts. They use a 50 milliwatt laser. They have a 50 square millimeter compute chip to supply all the data in. It has 30 megabytes of SRAM, so it can only do the small models. Because this is essentially a development. Can we build it?
Yes.
Right.
Yeah.
Lightmatter also has a 2.5D interposer type transport technology, which actually to me I think is more impressive, because with transport you split the light into multiple wavelengths, and that's how you multiply the bandwidth. With compute it's a bit more difficult, because you have these interferometers. When you change the phase of light, you're obviously changing how powerful the output is. So you have a 2% loss in fidelity, and then you're passing it through another 1,000 interferometers with a continual 2% loss, then your data at the end is going to be 0. So you can only do one wavelength of, maybe, I'm not an expert in this, maybe somebody can tell me, oh no, it's not like that. The way I see it is, in order to scale up optical compute, you have this 3 watt array that can do these sort of 8K ops, and then you just need another chip on top, and another chip on top, and another chip on top, and then you end up with a cube of optical compute. And you only need one laser light in, I guess, as long as it's got enough power and your interferometers can deal, signal to noise.
Yep.
As always, is important for that sort of thing. Though I've been hearing things that there's not been much interest in Lightmatter Mars. There's been more interest in the passage, the interconnect.
Sure, yeah.
Because
maybe we're just not ready for it.
Maybe
we're just not ready for it. I mean, they have. So what they have is a commercial product. You can buy it. You can buy a server with it in. But I think there's still there's a certain amount of resistance in the market. People are not ready to quite take a chance on this yet.
Well, also the way the compute works, like this whole sort of series of 1-bit operations, or what is essentially a matrix multiply engine. You still need to have the libraries to support it.
Yeah.
And then and maybe it's super fast at processing, but maybe pre-processing takes too long, or post-processing takes too long, and how does that fit into the rest of the machine learning?
Like the conversion from the electrical to the optical domain and vice versa.
Yeah, that also has a power.
Absolutely.
So it's a lot of companies are working on optical.
They all have the same challenges. Co-packaged electronics and optics, and the conversion and stuff that we're talking about, the lasers, and they all have the same challenges. But Lightmatter was first. With machine learning compute. Yes, so but they stand as good a chance, I think, as any others.
I mean, I still think the transport is still key in people's minds, and we've both visited AR labs, for example. Intel obviously has a strong optical electronics division with the networking, and being able to do future co-packaged optics. Intel even showed linking optics in package. It's a funny story actually. So they presented that innovation with their research lab in Scotland, which I had no idea they had.
No.
And for some reason they were all dressed in clean room suits, and they didn't need to be. Right.
That was just for show.
That was just for show, and they're basically getting a cable and just plugging it into a chip to do the optics. And I said, "It's in Scotland." can I go visit? And they went, we'll ask. And I said, well, I'm quite busy right now, but Q1 would be a good time frame. And they got back to me and said, yeah, Q1 would be a good time frame.
Oh, okay. Watch this space in that case.
Yeah, so let's go up to Scotland and get a nosy on that.
Absolutely, yes.
Yeah.
So see what they're working on. And we'll put the bunny suit on.
Oh yeah. But just the fact that you can have manual insertion of optical into a chip, that's a big thing. Assuming you can do more than 10 insertions, which is always a little bit of an issue. So after optical, we now go back to brain, kind of. Brain.
Yes.
Brain.
Hi,
Gordon.
Hi, Gordon. Rain is a very exciting company from my perspective. I think one of the things about Rain is that they are doing a lot of work on the algorithm side and then designing hardware as well to kind of go with it. So as we said in the earlier part of the show, one of the things that's most exciting is they are developing algorithms that allow for training to be done on analog devices. So it's like...
So is this reduced precision training, essentially?
It's like, let's scrap backpropagation and do something totally different.
If you can only do forward propagation...
So don't ask me how it works. Go and read their scientific papers or the work that they've done. But what I do know is it's a completely different way of doing it. But Rain for sure is at the beginning of this journey. I think they have working hardware, they have test chips. They're still doing a lot of work on the algorithm side. They have an installation at Argonne doing more like sensor calibration, I think.
Okay.
Which is very cool. But yeah, the hardware, the hardware is like nothing else as well, with these random connections between the elements, between the computing elements, which is again very brain inspired.
So is this neuromorphic or isn't it?
So it depends on how you define neuromorphic, which is obviously, I don't think you knew I was going to say that, but if you think of neuromorphic as spiking, no, it is not. If you think of neuromorphic as brain inspired, then it definitely is, right?
Oh, yeah.
So it depends how you see it, really.
It was funny because I think beginning of last year, you and I both met Gordon, one after the other. I had a meeting with him, and then you had a meeting with him. And so Gordon Wilson, by the way, CEO, incredibly young, like 30 years old, in charge of this company. And I said to him, yeah, you need to change your company name. For me and for everybody else in the tech space who focuses on chips, you say neuromorphic, you got to have a neuromorphic architecture. If you're brain inspired, then you're just brain inspired.
I mean, neuromorphic means different things to different people. We see this as well on the
one definition.
No, we see this as well on the sensing side with event-based sensing. It's like, how close is this to how the retina works, or how close is this to how the brain works? It's definitely. But I mean, how far do you take it? Right, there's lots of different types of brains that work, and not all brains work in the same way as well. So you could say it's inspired by insect brains, which are chemical and not electrical. Like there are different elements that you could take.
Yeah.
If you're only taking elements from how the brain works, because you're not using the same medium anyway. So if you're only taking elements, it doesn't matter which elements you take.
Yeah.
It sounds futuristic and cool as well, I guess. But
so my question for Rain is that they've been about for a couple of years, making noise for a couple of years now. And, these startups, they have some VC funding, and obviously there's a burn rate. So my question to those guys right now is, what's the plan? What's the end? What's the end game? What's the future goal here? Do we have another series round of funding? Do they IPO? Do they get acquired? Are they just simply, doing some more sort of fundamental basic research? I mean, maybe it's time just to have another call with them. I assume
maybe it's time to get them on the show. Yeah, maybe it's time to have them on the show. But I think, if I had to put money on it, I'd say probably another round of funding.
Yeah.
Before we're ready for any of the other things you mentioned. Still not really at productization just yet. I don't think we're still looking a bit further into the future with this. So, I think it's you're not going to be able to buy this in the next year or two. So, it's further into the future.
So after Rain, we spoke about IBM. If you've seen earlier episodes in the series, I spoke about the IBM EyeQ, Artificial Intelligence Unit, which is a 32-core AI chip design, inference down to Inter 2. However, in this episode, I spoke about the Z16 mainframe big iron computer that essentially financial institutions use. And on top of that, on top of its chips, the chips they call Telum, 8-core chips, 256 gigs of L2 cache, but also an internal AI accelerator, which is essentially one of these AI cores. And using custom interconnects on the chip, each core has access to the AI accelerator. As you might imagine, it's just a certain type of instruction, calls the AI accelerator, and the data comes in. And it's mainly used for fraud detection. So the reason why IBM is still in sort of this big iron mainframe market is because every bank in the world needs a system that has this sort of 6, 7, 8 nines uptime. So you're talking about 3 seconds of downtime per year or less.
Yeah.
But on top of that, you also need to be able to tell people if their money is being used incorrectly. I mean, we've all been there at a store, you tap your card on the thing, you want it to be approved, take your stuff, away you go. You don't want to sit there for 10, 20, 30 seconds while the system is waiting for the bank to respond, approve this sale, right? It's, we want a situation where the latency is the defining factor, not the approval.
Yes, yeah.
And that's kind of what this AI accelerator is going for here. I mean, chances are 99.99, 6 nines of people will never even do programming for this stuff. That being said, so Z16 is the system. It's the whole 5-rack system that's built on ZOS, and the point here is that you can run 40-year-old code on it. It still supports the old System 360 stuff back from the 70s. However, they do now have a new platform called Linux One. This was announced in September 22. When this show goes live, I may have already visited their facility in Germany, where they've got Linux Ones there, because they're basically, when you have a system like that runs Linux, even though it's still, the architecture is different, it means you now have a better platform for people to go develop on it. And the idea is that they're going to offer this stuff in the cloud as well. So imagine being able to run your own programs on mainframe grade silicon in the cloud with Linux and have access to the AI accelerator. So they're looking at different ways to productize this outside of the general. I mean, people have been saying mainframe is dead for decades because they're not in the public eye as much. But your bank will use one.
Oh yeah. This is infrastructure.
Yeah.
Yeah. This is not it's not your smartwatch or
no,
something, is
no.
it? That you see. This is infrastructure that we're talking about.
It's this is a machine that they sell hundreds to 1,000, maybe a couple of thousand worldwide through the lifetime. They may even set up to 10,000. I don't know. There's a lot of banks everywhere. In every country has at least 6.
Sure. Yeah.
And every one of those banks need the infrastructure in order to be able to support these sorts of transactions. And then, there's 1 million banks in Panama, so whatever. But yeah, it's an interesting design they've done on their chip. They co-package 2 chips into a socket, and you have 4 sockets per system. Then you have 5 systems. 5 systems per system. 5 systems per saleable product, and then that's what you sell to the customer. And so AI is going to be a fundamental part of IBM's roadmap going forward, alongside the traditional compute. And it just so happens that the Z16 system, the Telum processor, has a core.
Yeah.
I mean, I don't know. There's not a lot more to say about it than that. Aside from, I guess, to say AI is being is pervasive. Right?
Yeah, it's everywhere. Yeah.
It's hard to escape it, even in systems you thought were 50 years old.
Yeah.
Or antiquated. Yeah. All the new stuff plus all the old stuff as well. If somebody can make money from it, there's AI in it.
Agreed.
or blockchain.
No.
Yeah. So that leads us on to the last processor, Greenwaves.
Yeah, Greenwaves. Greenwaves have been around for a little while. Here in Europe, in France, so they have a RISC-V design. They have a multi-core RISC-V design. Again, we've spoken about RISC-V before in the last few episodes. It's quite cool because you can just make your own instructions for whatever you want, right?
Yeah.
I'm making it sound easy, but you have that customizability that you don't get elsewhere. So, yeah, they take these RISC-V cores that are optimized for the application. They have an AI accelerator on there as well, and they have, they do clever things with they have a big L1 cache there that they use, and they
that's
have
a shared one.
That's right,
which
yeah.
is weird in a little way.
So it works.
Okay.
It works. They have terrific benchmark results. They certainly use very, very little power to do very complicated, much more complicated audio than you'd probably imagine in such a small device. They have also this sound filtering unit that takes some of these audio tasks for like noise cancellation, stuff like that, filtering and spatial audio that comes from different directions, but then you turn your head and it still has to come from that direction, which is kind of a cool one.
Yeah, it's funny that. So I was recently at Qualcomm's Tech Summit, and they said their new chip now has this sort of second generation spatial audio. I mean, spatial audio has been a thing for a while, where if you have 10 different instruments at different locations around you, and how does it essentially multiply those sounds together to make it so it feels that way, even if you're only in a 2.1 system. But spatial audio first gen meant that you turn your head and all the instruments would turn with you.
Exactly, yeah.
So the second gen is you turn your head and the instruments, but that requires additional calculations. This has been a thing in the gaming industry for quite a while, but it's a very compute bound task.
Sure.
Because you have your standard sound wave, you have it you then have to calculate where, say in Counter-Strike, the person who's, running up the stairs, where the sound is coming from, where is it bouncing off? And so then what multiplicative factors do you have to add to that sound wave, along with the 50 others that could be in the scene?
And do it all in like real time.
And do it in real time. Yeah. So with older machines, there was always a fundamental limit on how to do that. Because I remember digital audio workstations saying, well, we've got to deal with 300 simultaneous samples, and it's a strong workload. So now being able to do that with AI.
Yes.
Yeah.
So Greenwaves has a lot of partners that they work with on the audio side, little companies making these kind of audio applications, and they had a whole load of demos at Mobile World Congress last year where they showed off all different kinds of things, and it was very, very cool. I have an article about it on eTimes, which you can read for more details about all these demos, but yeah, ultimately they're going really strong on the audio, I think is the message from them. They feel like they found their niche. They were previously doing person detection, occupancy detection, that kind of thing, more like camera applications, but for audio, they feel like there's a space there that they can move into, so that's where they're headed.
So, I mean, this has been a crazy, eclectic mix of an episode.
Once again, completely different.
It's the AI market is so huge. You can pick any two chips and find out they're not at all related. The only thing they do the same is process ones and zeros. Or not.
In some cases.
Not. That's even better. It's even better. Awesome. Well, again, thank you very much, Sally.
Sure. Thanks for having me on the show.
And if you guys are watching as this is going live, well, we got another episode coming next week. If you're binge watching, then stay tuned for the next one.